Okay, we can start, I think.
Okay, great. I'm Jonathan Clark. I've been working on LibreOffice for about a year to improve language support. I'm an employee of the Document Foundation. First, I'd like to thank everyone for the opportunity to talk about language this morning. It's 5 a.m. here, and I'm quite caffeinated, so thanks everyone for joining me on this trip. And before we get started, I have a little bit of a sales pitch for everybody. I've been thinking about this for a few years. The way we write English is a little bit rubbish, isn't it? You always have to memorize how words are spelled, and you can never know how to pronounce a new word if you read one. But we have other options. So what I propose is we adopt a new writing system called Emoji English. We generally keep the alphabet, but we can replace some of the text with emoji. This will save time and aid reading comprehension, since now you can easily spot what a sentence is about just by looking at it. So, for instance, we can write, instead of writing the dog and the red ball out in full, we replace the word dog with the dog emoji, and red and ball with red and ball emojis. Apologies to anyone who is colorblind. English isn't a great fit for this kind of writing system. It's not what linguists would call an isolating language. So we need to keep the English alphabet a little bit so that we can continue to write our suffixes. We change the way we write words depending on how they're used. So, for example, Sally climbed up the mountain. We still write the ED at the end of climbed. If you're worried that there aren't enough emoji, we can combine them into longer words. For instance, I think a marathon is a long foot race, so let's use baguette for long, person running, and flag for foot race. We're good. Bob is training for a marathon. There's lots of unassigned code points we can add more emoji for, but we may not have to. There are more emoji than you would think. If you look at the Unicode standard, you'll find that this means we can do it, and we have a lot to gain. Those don't really make a lot of sense to me, but they're in the standard, so you can probably trust the Unicode committee. So I strongly recommend that everybody start writing English this way immediately. Everyone will be very impressed, especially your customers. All right, I have some disclaimers to make. Language was made by people. People are a quarrelsome bunch. Discussing similarities between languages or implying heritage between languages can be a sensitive subject. Don't try it at home. Some of the more interesting examples of language use come from interesting people. I generally avoided anything too controversial today, but in general, I don't endorse the content or sources of any examples that I use. And every language is complicated. People make entire careers out of studying a single language. There is absolutely no way that in a 45-minute talk we can cover any of them substantively. Don't get offended if I overlook something that you think is important. All right, if you've ever attended a LibreOffice community presentation about languages in LibreOffice, you have seen a table that looks like this one. Software developers divide languages into 4 categories. You have our Western, our easy case, or as some software developers seem to treat it, the default case, right to left languages, complex text layout languages, and the CJK languages. As you can see, Arabic belongs to both the right to left and complex text layout categories, and it is considered both. These are not disjoint. Now, you have heard people say Arabic is a right to left language and Arabic is a complex text layout language. So you would probably conclude that these categories are, in fact, about languages. However, I don't know about anyone else. I have never heard anybody speak Arabic right to left. We don't care about languages, we care about the written form. So we probably care about writing systems. A writing system combines a set of symbols called a script and rules, which we can use to represent a particular language. So for a practical example, we can take the Japanese hiragana script, and we can take some basic rules for how the characters are assigned to phonetic values, and we can write a Japanese sentence. You may not be able to read this, so I will provide something that you can. This is a different writing system for the same language. So writing systems are not the same as languages. Languages can have multiple. By the textbook definition, a writing system cannot have multiple languages. The rules are different. For example, in the previous slide, I used something called the Hepburn romanization for Japanese. But that's a technical distinction. So we intuitively know that if we wrote Japanese using the Latin alphabet, using substantively the English rules for line breaking, etc., it's not a CJK language anymore. We don't really care about the writing system or the language. We'll just give a different dictionary and call it a day. So we don't care about languages or writing systems. What do we care about? We care about ourselves. So why did we invent this scheme? We're not saying anything insightful about language. We're just doing it as a requirements gathering activity. We want to give languages a set of minimum system requirements. And so our table shouldn't look like this at all. It should look like this. So for Western languages, rendering text at all is table stakes. Any piece of software is going to end up doing it, if only because we want to be able to debug them. For the right to left languages, we need to have bidirectional text layout. For CJK, our implementation needs to be robust. We need to be able to handle our boundary conditions very efficiently. And for CTL languages, we need this nebulous family of font rendering features called complex text rendering. If you've ever looked in the LibreOffice codebase and wondered what some of our dependencies are there for, I provided some pointers in parentheses. Now, by engaging in this sort of language classification activity, we've put our feet in a kind of a bit of a tricky subject. The basic operation of linguists for the past forever has been trying to classify languages depending on their features. Well, natural language is a product of physics and convention. So we know certain things that can constrain the development of languages. We know about human physiology and the material properties of our writing implements. But convention is we do things this way because that's the way they are done. Language is the product of complicated historical events and personal preferences. It's billions of tiny decisions over thousands of years. And so I can tell you a lot about this tablet. The author of this tablet was very upset about the quality of a copper shipment. I could tell you it was written in clay. If you've ever worked with clay, you know that you can't scratch complicated shapes or lines into it with a stick. You really have to push your stick into the clay if you want to have a legible mark. And if you happen to use a particular sharpened wedge-shaped stick, you are going to end up creating a distinctive wedge-shaped pattern that future generations may name your writing system after. I could tell you that this text is written in a language called Akkadian. It's read from top left to bottom right. I can tell you that a few hundred years before this, it was written from top to bottom, right to left. At some point, they decided to rotate their entire language, symbols and all, counterclockwise. I don't know why they did that. I guess they just liked it better that way. And so when you start investigating individual languages, what you find is that no writing system really fits neatly into these categories. Pardon me. So we don't just need to worry about these minimum system requirements. We also need to worry about these recommended system requirements. Now, in order to do this, what I recommend is that we adopt the same mindset that linguists have when they study languages. Linguists are firm believers in what they call linguistic descriptivism. It's a philosophical belief that we should objectively study how language is actually used in the wild by native speakers, without any biases about how those languages ought to be used. And the other thing that's important is to keep our programmer mindset. Looking at a language that we don't recognize can be intimidating. After all, we don't recognize it. We're constantly being trained to ignore things that we don't understand that look like writing as noise on product packaging, etc. But text is just data. A word processor is just a program that converts data from one form into another. Programmers are very good at converting data from one form into another. If you want to understand what that conversion process should be, we can use secondary sources like Wikipedia articles. And it's surprisingly easy to conduct primary research. If you go to your favorite search engine, type in newspaper, space, and then the name of a language, you are going to find more sample data than you will ever know what to do with. And so I'm going to kind of run through a couple of languages and show what you can do to actually perform this requirements gathering. But first, I want to give a little bit of information about what Chinese characters are. And so Chinese characters are considered the longest lived writing system in continuous use. They've been in use for a few thousand years. They've changed significantly over this period, about as much as Egyptian hieroglyphs have changed to turn into the Latin alphabet. I'm not entirely sure why we don't consider that continuous use, but whatever. Chinese characters can be decomposed into components. As you can see on the right here, this nose character consists of 4 other characters stacked on top of each other. Components can be positioned to the left, right, top, bottom, around other components, and basically anywhere you want. There's no authoritative count about how many components we exist in the wild. But if you remember anything about discrete math, you can probably detect there's an issue here. We end up with a bit of a combinatorial explosion. I counted just shy of 100,000 unique code points in the Unahan stroke count database. Those are distinct characters that were observed in the wild. There are a lot more possible characters, but we don't have Unicode representations for all possible characters. And each character has its own semantic value. As you can see here, this nose character decomposes into oneself and give. The components used to represent a character don't need to have any meaning, don't need to have any bearing on the meaning of the combined character. It's just the way that they're written. So Chinese characters are considered logographic. And what that means is that each character in the writing system is a morpheme. And what that means is that each character has its own semantic value. It's kind of like a word, but not entirely. So if you compare that to the English writing system, individual English letters don't have any semantic value. The semantic value only comes when those characters are combined into one word. But for Chinese characters, each character has semantic value. So in this case, this character means hand, this character means machine, and when combined into a single word, you get the Chinese word for mobile phone. Another complication is Han unification. So this was an effort to reduce the number of code points that are used for CJK. This is kind of a debate. The issue here is that any program that needs to display text in multiple CJK languages needs to track what language that text is written in. And that needs to be stored separately from the actual text content so that the program knows to switch to a different font for different languages. If your dream of shipping a single font that covers every language didn't die when you saw the number of potential Chinese characters, this kills it. All right, so with that, now we have the Japanese writing system. It uses kanji, which are the Chinese characters, hiragana, and katakana, 3 scripts. If you refer back to our definition, our textbook definition of a writing system, you will see an issue. This definition is perfectly fine. It just illustrates the complexity of trying to define anything in human languages. Japanese does not use a set of symbols called a script. It uses 3. If you look at the same textbook, you will find that the kanji are supposed to be used, generally used for Chinese words and stems of certain Japanese words. Hiragana serve a grammatical function, are used for native words, suffixes. Katakana are used for loanwords. But all of these also serve literary functions. Chinese characters are used for abbreviations and for their semantic value, independent of how they would be pronounced as part of a complete word. Hiragana can be used to represent any Japanese text, depending on the preferences of the writer. Katakana is often used for emphasis in literature, to affect accents in text. For instance, a robot in a children's comic, for instance, would be written using their text would be written in katakana. So here's an illustrated example of what this looks like in practice. The blue text is kanji, the red text is hiragana, and the green text is katakana. In this example, katakana is indeed only used for loanwords. Hiragana is used for grammatical particles, and it's used for what's called okurigana, which are the endings of certain indigenous Japanese words. The kanji, the one exception, which I pointed to on the previous slide, is this one. This kanji is used as an abbreviation for the United States of America. As you can clearly see, there are no other scripts used on this page. There's no Latin on this page whatsoever. There's no Latin used on this page, and there's no Latin used on this page. So Japanese is only written in 3 scripts. We've confirmed that. Well, according to the textbook, that's absolutely correct. Japanese should only be written in those 3 scripts. But as I said previously, we are software developers. We don't really care what the textbooks say. We care about what things are in practice. And you are not going to get very far if you write software and you cannot support embedded runs of Latin text inside of Japanese. When you look for it, you will see it everywhere. Another neat feature of the Japanese writing system are these Ruby characters. If you've ever looked at Japanese text, you have seen them before. They're these little guys that sit above the Japanese text below. The Japanese name for these is furigana, and that literally means assigned kana. The dictionary definition is it's a reading aid where you use kana printed above or next to other characters to indicate pronunciation. Are these characters actually used this way? They are, but they also serve a literary function. So if you were a programmer and you read that definition before, you can probably imagine some useful optimizations. For example, why do we bother storing the text for Ruby characters when we can just use a pronunciation dictionary and look up what the text should be? Well, if we did that, we would break some fairly common use cases. Ruby characters are used to assign kanji to loanwords, disambiguate pronouns, add subtext in literature. More importantly, they're not always kana. You can have arbitrary text above and below. So, what we've gathered today are minimum system requirements for Japanese. We've confirmed that we need to be able to handle an extreme number of glyphs, particularly large fonts that contain many glyphs. Fonts, by the way, can only hold about 65,000 glyphs, last time I checked. So in certain cases, we may need something to deal with that problem. As a useful pessimization, well, it's not terribly common, but it is possible for every glyph on a screen of text to be unique. And so in the interest of optimizing for our worst case, we should probably be able to handle the case where every glyph on the screen is unique. To support Japanese text, we also need to support a complete copy of the English writing system embedded within it. And that keeps all rules intact, including the way that we break lines in English. We do not want to use the Japanese rules for line breaking for these embedded runs. There are more, but that's all we have time to gather today. We also have a number of recommended system requirements. In this case, we looked at Ruby characters, and we need to make sure that they can have arbitrary text on the top and on the base, and that includes putting Ruby characters on English runs or putting English runs inside of Ruby characters. And the last language I want to talk about is the Hebrew writing system. And again, we see our definition is modern Hebrew is written from right to left using the Hebrew alphabet. The Hebrew alphabet is literally called alphabet. So if you've never realized that Hebrew and Greek have a common ancestor, this is your first clue. Is Hebrew actually written from right to left? In general, yes, but numbers are written from left to right. And it's also common to see left to right runs of Latin characters inside of Hebrew documents or websites. And so this confirms our requirement that we don't just need to support right to left layout, we actually need to support bidirectional layout in order to render Hebrew. And bidirectional text mixes left to right and right to left text, generally involving different scripts. And just to give you a visual example of the way this is meant to work, if you've never experimented with this before, we start on the right with our right to left run of Hebrew, and then in quotes we have our left to right run of English. When we do line breaking, you could see that the English text is rendered as if the line width is narrower and it's right aligned. And so as the line width narrows when we break, we still end up writing the first English word on the first line and then wrap the rest of the English span onto the next line. It makes intuitive sense when you understand that's what it's doing. But as a programmer, I know that the first time you see it, you generally would expect that, well, we're rendering from right to left, so why don't we just break the line here and wrap everything up to the left of it to the next line? So just a little complication that you may not have noticed as you're looking at documents that contain right to left text. Hebrew is written in something called an abjad. The dictionary definition for that is a script which contains only consonants. I can tell you is that this is not technically true for Hebrew, but in practice, it kind of is. They have these vowel-ish things that are also consonants. I don't entirely understand it, but the important part is that in Hebrew, a verb, for instance, is defined by a root consisting of 3 radicals. They don't. The vowels themselves are determined by a predictable pattern that can be inferred by readers from context. And so as a verb is inflected, the vowels themselves will change pronunciation. They don't need to write all of the vowels in order to know how a word is pronounced once they've learned the pattern. But for learners, they have a pronunciation guide. And so the vowels can be represented in Hebrew using diacritical marks. In order to render diacritics, you should use harfbuzz. If you ever write a new program that renders text, use harfbuzz. There are roughly some dozen font features that you need to support if you want to support diacritics properly. It's not worth your time. Just use harfbuzz. And the great thing is that in addition to supporting diacritics, you end up getting a lot more out of it. An example of this is that you get better English typesetting, like ligatures in English. You need to support these in order to get your diacritics in Hebrew anyway. So you may as well just use harfbuzz and then you get it in English as well. Now, that gives us these minimum system requirements. So we've confirmed that we actually do need bidirectional text layout. We can't just get along with right to left text layout. We also know that we still need to have a complete embedded English writing system, along with all of the rules that come along with English. We've gathered some recommended system requirements. So a software system that we want to use to render Hebrew needs to support combining marks, diacritics, ligatures. I say that none of that is real. What we want is this complex text rendering cloud that we get from harfbuzz. And so to support Hebrew, we really ought to support complex text rendering. Now, I want to leave everyone with a little bit of food for thought. We have this minimum system requirement for English, or table stakes. Any degree of text rendering can support English, theoretically. English fonts can have ligatures, and we really want to support those for professional looking output. And we want to say that's a recommended system requirement because you technically don't need it. People will just laugh at your software if you don't support it. But it's 2025, and I think any credible text rendering engine should support these font features in English too. And so I claim that in the modern age, ligatures are a minimum system requirement for English. So complex text rendering, which we get for free by using a modern shaper, is a minimum system requirement. Japanese embeds the complete English writing system, so complex text rendering is a minimum system requirement for Japanese. And then if we go back to our original table, it kind of looks like Hebrew, English, and Japanese might be complex text layout languages. Just something to think about. And that is the end of my presentation. I think we have some time for questions if anybody has any.
Thank you, Jonathan. Yes.
Yeah. What a great talk. I love it. Thanks so much, Jonathan. It's really good to just give a nice overview of all of the problems that are there if you're not expecting them. I recall talking to some of the people back at Sun, some of the architects who should have known better, who really thought that the length of the string could be determined from, the number of characters, and thus UTF-16 was a good thing because you could work out the length of the string from, just, which of course is so silly as to not be possible. But just to go into a little bit more detail there, currently we spend absolutely loads of memory, at least for Latin systems, using UTF-16 or maybe UCS2, depending on where you're at. Should we, or should we switch to UTF-8? What's your, take?
My take, that's a good question. I think there is a boundary where it's convenient to switch to UCS4 when you are actually rendering your text at the back end. I'm not entirely sure what HarfBuzz uses internally. I imagine it is UCS4. I don't... We already need to consider multi-byte character sequences. So when we're processing UCS2 strings, we need to treat them as if characters can be longer than 16 bits. So I don't think we would lose anything by migrating that to UTF-8.
Awesome. Well, that's an encouraging thought. In the Star Trek future, where we can change the ABIs and something, switching to UTF-8 for all strings then might be a good memory saving and efficiency one. Thank you. And just great talk. I'm sure others have questions.
Okay. Thank you. Aaron, Attila, questions?
No questions. Thank you.
Thank you. Benobe Beram, questions? Banobe? Okay. Kellen, Clove, questions?
Yes, I don't have any major questions, but first things first, and I just throw that link in here because it's one of my favorite words that I can't pronounce about ancient Greek, which is bidirectional, and that it goes left to right and then right to left. I guess it's not something that matters to any current language, but I was fascinated by that. But otherwise, what we've come across especially is languages that don't have spaces in them as obvious word boundaries, and as a Khmer comes up as an example of this quite often. Do you have any kind of insight into what's going on? Because there's always this constant issue of trying to improve the dictionary to provide places to line break, but then nobody seems to agree on what the rules are, and it's a recurring theme. Do you know anything about that?
Well, first for Bostafridon, that actually ended up on the cutting room floor for my talk. I didn't have time to rehearse, so I didn't know exactly how long it was going to take. But yeah, that's a fascinating example. And I believe it's Phoenician, which is the common ancestor of the Hebrew and Greek. The directionality of language was still in flux at that time, and it's just kind of an accident of history that Greek ended up being written left to right and Hebrew ended up being written right to left. So it is very interesting, and even just being able to write in the path that a goat follows when plowing a field is an interesting point. So for dictionary-based break iterators, I'm not. So in general, Chinese languages and Japanese don't use spaces, but they also don't use a dictionary-based break iterator. They have a different set of breaking rules called forbidden rule processing. I think Thai is the main example of a language I can think of that uses a dictionary-based break or iterator for line breaking, but I don't know much about Thai, so I don't know if I can comment too much about any debates or disputes that are happening there.
Yeah, no, it's just that it comes up regularly that sometimes people attempt to add rules, and then the rules get backed out because of problems, and it just sounded like something that maybe somebody should standardize, and I just wondered if anybody was standardizing, but if we don't know, we don't know. That's fine. And
Well,
this was just go ahead.
Just kind of tying into the main thesis of my talk. In a lot of cases, there are no definitive answers. I mean, language is complicated, and people are entitled to disagree about it. Standards are nice, but that's not necessarily how things end up being used in practice. It might be nicer to provide better tools to indicate when lines should be broken or shouldn't be broken. Just make it easier for those users to kind of express their own opinion about the way things ought to be.
Yeah, and I suppose the last thing then, a question is, some of the other software I've seen, when we come to these runs that are in a different direction than the, say, parent runs, or let's say Arabic with embedded English, they have a much kind of nicer cursor with little arrows on it that indicates kind of maybe various levels of directionality or something, whereas our own cursor seems a bit bland in comparison. Is there any kind of thoughts around that, whether a cursor indicator is useful versus other people's software?
Yeah, so I think that's an area that we can improve, and there are a number of bugs that are open to track that. I think we were supposed to have arrows on our cursor, but I think they may have been removed due to a severe performance regression on certain systems. I can't remember off the top of my head. If you've experimented with certain text editors, you may see that they have a split cursor. So one cursor indicates where the text will be positioned if it's RTL, and the other if it's LTR. And that's useful because if you're typing the two directions kind of at the same time naturally, you get kind of confusing results if you're not familiar with what to expect. So I do think this is an area that we can improve.
Yeah, sounds great. Thanks.
Thank you. Darshan, Gokai, Heiko,
Nope.
Jaume, Joao, Justin. Okay. Miklos,
I will have a small one. So what can happen easily to kind of any of us is we get some bug report about some rendering bug, and you get the screenshot of the good and the bad rendering, and it's in some non-Latin script. And at first you can't even easily spot the difference between the good and the bad version because it's so not obvious. And then you slowly learn about what are these kashidas and diacritics and accents and. Yeah, do you have any recommendation on like any good learning materials to just to learn into this a little so that at least we can speak about this domain as programmers because we would know the name of things and so on. Or these special things which are outside the Latin script.
I'm not, I'm not aware of any definitive single source that you can use. If you're curious about specific languages, looking things up on Wikipedia is actually surprisingly good. I would say it's not necessarily the most technical, accurate definitions for certain linguistic terms, but again, we're programmers, so we don't really care about those. So yeah, I mean, you can look up Kashida or Tatwil Arabic justification on Wikipedia. That's a great place to start. You'll see lots of examples for those kinds of things. Unfortunately, just there are so many languages and there are so many corners, so many nuances in every single one of them that realistically you aren't going to be able to learn everything that you need to know to spot all of these bugs all the time. You just kind of have to take them as they come. And if you're really interested in a language, by all means, you should study it in greater depth.
Thank you.
Thank you, Mevan.
Yes. So English in your example might also include other Western languages. I'm thinking about accents for Latin languages, I'm guessing.
I'm sorry, I had trouble hearing the question.
Just thinking that in your slides you are speaking about English and CGK or other languages, and I'm thinking about other languages that do use Latin letters, but with more accents. So I'm guessing in your presentation, English would also include them, right?
For instance, so Vietnamese. It's a good example of a script that a language that is typically written using Latin script, but has stacked diacritics.
Mm-hmm.
Yeah, that's an example of a Latin using language, but also requires CTL features in order to properly render everything, at least as far as I know.
All right.
I guess Mevan is thinking of French, being French, but
Spanish and German and all those other Western languages that are
yeah, but it's fair enough because French has quite a number of diacritics, but presumably those are typically a single glyph in each of the fonts, are they, or are they composed?
Fonts generally offer separate glyphs for every diacritic, so that's just in the Unicode standard. But I think that usually a shaper engine combines it into a single glyph that has the accent positioned, at least in the case of French.
Cool.
Thanks.
Okay. Michael Vecord. Questions? Okay. Michael Stoll. Okay. Part. Questions? Pranam.
No, thank you.
Rush. Questions? Richard.
A less technical question, but I'm curious, Jonathan, how did you first fall down this rabbit hole of languages and diacritics, and what was your original connection to all of this?
One semester of an undergrad linguistics elective.
Amazing. And how many of these languages do you have a decent understanding of personally? You seem to talk very authoritative about all of them.
So I, depending on how you define decent, the only language I know is English. I have been studying Japanese to learn how to read Japanese for a few years, but it's slow going. I don't live in a country where it is regularly spoken, so I don't get a lot of exposure to it. Just to refer back to an early slide that I had, it's always useful to maintain programmer mindset, and language is just data, and we're just interested in converting it from one form to another.
Yeah, it's great. It was a great presentation. Thank you.
Okay, Stefan, questions?
Thanks for the talk. And just one comment about these ligages in Western languages like German. I think the only thing that is worse than a typesetting system that doesn't support ligages is one that always uses them, because at least in German, often you don't want to ligate like FL and FF. And if people don't mark up their content with the Unicode non-joiner or whatever it is, then the result is more shitty than if there is ligatures enabled. So be careful with enabling ligatures.
Yeah, I don't think we have a decent solution for that other than the zero width non-joiner.
Yeah, but people often don't add it to their text, and then you even read books and newspapers in German where it's sloppily typeset, of course, and then looks crap. Just a comment. Thanks for the talk.
Yeah. If I can stick in another question, Jonathan, you tantalized us with the cutting room floor and things that you'd left on it. So, I mean, one of the things is their text grid, which is reasonably complicated. Would you come back and give us some more, go even deeper down the rabbit hole?
Yeah, at some point in the future.
That would be fantastic. Thank you.
Okay, I think that's all. Thank you, Jonathan, for the presentation.